Okay, so today we're talking about your VM in the cloud. I'm Saverio Proto from Switch. I have some initial nice slides with nice graphics from our marketing, and then you will see the not nice slides from me that are more like techy. So you will see the difference in the graphics, I guess. So first of all, who I am and what is Switch? So I work in the infrastructure and data services, and what we do is infrastructure as a service with OpenStack for the Swiss academic. So we are completely Swiss-made. This is our added value, that all we do is done here in Switzerland. We have this OpenStack deployment with 2 regions, one in Zurich and one in Lausanne. And why we do infrastructure as a service in this, let's say, smaller scale? Because we all know there are the big players. There is Amazon, there is Azure, but what we try to do is to make a service for our community, for this community, the Swiss academics. So we try to make easier onboarding, and we try to design the services in a way that makes easier for Swiss academics to work. So these are our customers, so universities, but also spin-offs and research institutions. You know the story. And what are we going to talk about today? SWITCHengines, our OpenStack Cloud, is going to offer a virtual private cloud service. This means that you are going to be able to log into our platform and start a VM, and the VM will appear as if it is in your campus network. So this will enable faster integration with your existing services, because you can just add VMs to what virtually is your campus network. So if you need any kind of layer 2 connectivity between what you already have and the new VMs that you're going to start in the cloud, that's going to be possible. This was a project started within ScaleUp. ScaleUp is a research project that Switch is involved in. We will see more about this later. So here is a summarization of what I told in the previous slides. I go fast on this marketing stuff now because it's boring. I want to go to the tech details. Okay, virtual private cloud. What's the goal here? What is difficult about cloud when you start? You probably never start from scratch. You always have something at your lab or at your university, and you have to migrate workloads from what is existing to the cloud. And this is something that you cannot ignore, because nobody starts completely from scratch. And a pain point for a lot of users is the campus firewall. So you have some workloads and you want to extend them, but you feel very uneasy to make the 2 things work together because of firewalling rules. So the benefit of the virtual private cloud is that you will see these VMs already behind the firewall. So you can start the VM and you decide when we set up the system on what network these VMs will appear. You can use this setup for several things. So one is to enhance with redundancy. So you can have a setup where when your local infrastructure fails, then the VMs in the cloud act as a backup. Or you can use the VMs in the cloud to scale out. So when your capacity is finished, you can add more capacity adding VMs from the cloud. Okay, let's see who is involved in this project now. So we started this as work package 10 in the scale-up research project. SWITCHengines is our infrastructure as a service running on OpenStack. At the moment, we are running OpenStack Mitaka, and we plan the upgrade to Neutron by the next month, so it's really updated. If you're familiar with OpenStack, you know that large installations are usually many releases behind. And the person involved are Fachhochschule St. Gallen and Switch. We are having this first trial where they are actually installing some services in the Switch cloud, and these services are appear as if they are in the network from the Fachhochschule St. Gallen. So at the moment, there is an installation with a Domino web server and a Windows domain controller that acts as a backup for the Fachhochschule St. Gallen, and this is running in our testing environment. So how did we implement this? There is a network tunnel, of course, no? So no rocket science here. We have to make a tunnel from the customer side to the cloud side. So the problem is split in two parts. There is a network tunnel that goes over the switch backbone, and then there is a tunneling mechanism from the OpenStack tenant network, that is a virtual entity, to a physical segment when I hook up a wire. So we are going to see these two separately. Okay, here is the figure that tries to explain the thing. So on the upper left, where is this cloud, this is the OpenStack cloud. So you have your SWITCHengines VM, and you have a tenant network. Now, a tenant network, it's just a set of VXLAN tunnels. So you have many VMs spread across multiple hypervisors, and you have VXLAN tunnels that make the illusion that these VMs are all in the same layer 2. And then you have a OpenStack network node, that is where your floating IP ends. And you have a provider network. A provider network is a physical segment. Then you get out of the cloud data center, and you have to reach the customer network, the university. Here we have these routers. Those are routers from the switch backbone. And we set up a VPN with 2 VPN boxes. So when you subscribe for this service, we really come at your premise and we deliver one of these boxes. We'll see a picture later. And you have one of these switch boxes in your rack, and that's where you hook up the network to see the remote VMs. So here we talk about the backbone. The VPN box is a device that was developed as Switch and makes VPN tunneling over IPv6. We will, it's called the Alex box, Agile LAN Extender. So the idea is to have a layer 2 connectivity over IPv6 encrypted. Okay, now let's see the detail of the tunneling inside OpenStack. So here we started this project when we were running OpenStack Kilo, and the tooling to achieve this goal was not completely ready yet. So our first prototype was in layer 3. We had the ability to reach with this private network in the customer network, but we had to do a layer 3 setup on the OpenStack network node. So basically what you had a tenant network with your VMs, and then there was some routing done at the OpenStack network node, and then the connection was direct to the customer. How do we realize this setup? If you are familiar with OpenStack Neutron, you have to make sure that you have all the type drivers enabled. So your OpenStack Neutron should be able to handle VXLAN networks, but also flat networks. And then you have these bridge mappings. So on your network node, your network node is a physical box at the end. You have some network interfaces. If you have a simple OpenStack setup, your network node as one physical network interface to the external network. In our setup, we have many because we're going to have the common external network for the internet access of the VMs, and then one interface per customer. So we have to map these physical interfaces into the OpenStack database, and this is called the bridge mappings. And then once this is set up, the OpenStack operator will create a physical network, and this is the command that you need. This is a long command, but I made sure everything was here so that when you download the slides later, if you want to try this setup, you have everything that you need. And then you see that basically here you create the connections within the network node. This operation has to be done by an administrator, because here what are you doing? Here you are really mapping an OpenStack network that belongs to a tenant. You are mapping it to a real physical interface, and this physical interface is connected to the university. So this is not an operation that a user can do, because otherwise any user could create an OpenStack network that is directly connected to the university network. So this is the only step that admin is required. And once this is done, the user with his normal credentials can set up all the IP addresses that are needed, and the DHCP if needed, and so on. Okay, and last part, we create the router in the OpenStack network node, and we attach these two networks. So summarizing, we have the usual OpenStack router in the network node, the namespace. On one side, you have the tenant network where are attached the VMs, and up to here everything is simple. But on the other side, you have this network that is completely, directly physically attached to the university. And this is set up by the OpenStack operators for you. So you can have multiple virtual routers also depending on your tenant topology. Okay, this was working already like 6 months ago, but still was very complex to set up for the users, because there was this layer 3 between the OpenStack Cloud and the university network. So we wanted to realize something more simple that was completely layer 2. And we made use of a new plugin for Neutron that is called the layer 2 gateway. So we have a new box between the tenant network and the physical network that is not anymore the classical OpenStack network node that needs routing, but is a box that makes a simple layer 2 bridging. This box can be either SDN switch, so a switch that has to support the OpenVSwitch VTEP, or we can use just a server and run OpenVSwitch on it. In this case, the configuration is much simpler because it's a layer 2, so we don't have to go in the detail of all the routing and the next stops between the tenant network and the university, but we just have to set up we have to set up the Neutron server to manage this hardware switch. So with the first command, basically we instruct OpenStack that there is a switch in the data center that we should manage within Neutron. And with the second command, we create a connection between this physical switch and the tenant network. So here the configuration is much easier. What is harder is the installation, because this layer 2 gateways is a very new feature in OpenStack and is present only starting at OpenStack Neutron. Okay, let's give some details about the hardware. So at the moment we are using this box from Avantech. There are several 1 gigabit Ethernet interfaces and 2 10 gig interfaces. This box is the one that we deliver at the university when we start this service. So there is one in our data center and one at the remote sites, and it's the one where the IPv6 tunnels are terminated. So what do you need to use this setup? You need IPv6, but you don't need IPv6 at the university. You need it only at the border router. So this requirement is always satisfied because the switch backbone has IPv6 everywhere. You need IPv6 inside the university network only if you want to terminate the tunnel somewhere else. So if you want to terminate the tunnel deeper inside the campus network, then we need IPv6 endpoint. But if you want to terminate the tunnel at the border of the campus network, it's okay. And then you need the MTU bigger than 1500, because 1500 is usually what you want to deliver to your VMs, because we have another layer of encapsulation. You need a higher MTU. Here we say that this can be placed deeper inside the university. What I mean is that you can have a setup where the box is connected directly to the switch router, so completely independent from the internet access of the university. Or you can have a setup where you have the box installed in the rack of your lab. So even independently with the, you don't have to coordinate with the networking team at the university, you just need an IPv6 address where to terminate this tunnel. So there are some notes about the software on this box. It's called Nixos. It's a special Linux distribution. This is a work done at Switch by my colleague Alexander Gall. I will not say a lot about this because it goes out of my knowledge domain, but if you want to know more about Nixos and the software internals of the Switch, you can get in touch with me or with Alex Gall. We also considered the alternatives to this solution. So if you want to start some VMs, and these VMs have to participate in something that you already have on premises, what is that you can do alone without our support? So you can use the OpenStack VPN as a service, but this is not really a good idea because it's not widely deployed and also is going to be deprecated. You can use a dedicated VPN VM. So this means you have a tenant, and on one VM you install Think VPN or Open vSwitch, and you manually take the burden of configuring the tunnel, and all the traffic of your tenant then goes through this software VM. That is a potential bottleneck. Or you can include the VPN client in every VM. So you have some VMs that start on SWITCHengines, and each one of them makes a tunnel to your application on premises. So, of course, all these solutions require some work and put a block to the users to start to use our service. It's much easier when you start a VM and that already appears in your network and you don't have to do anything to set up. Okay, the next steps. So we are upgrading to OpenStack Newton in 1 month maximum. So we are going to be able to offer this in production. We have already this pilot with the Fachhochschule St. Gallen. So what we are going to do is we are going to get users in beta for 2017, and this is going to become a real production service in 2018. Especially for the layer 2 part, this is very new also in OpenStack, so we are really welcome if other OpenStack operators want to try this out, and we can give all the help to widen the user base of this Neutron plugin. And also switch vendors SDN that want to test the interoperability of their hardware appliance with this plugin. So we know that with Cumulus Linux, that is the brand that we run our data center, this works because just needs the VTAP schema. And we also tested with the vanilla Open vSwitch, but at the moment all this stuff has to be investigated. So here is my email in case that anyone wants deeper information on this. Okay, so I conclude informing you that we have a celebration this year for the 30 years of Switch. And if you are in Switzerland, you will want to find out more on this Switch.ch 30 years, because there is some special things. And if you have questions, I think there is still time, yeah? Yes, sure. Yeah, no, the idea is that you want these VMs to run in the cloud, but really with the same feel as in the campus network. So there are things that are very important. One is the latency that has to be as low as possible, and basically you cannot afford to have packet loss, because you want to have the feeling that this system is really in your same layer 2. So any software tunneling was probably going to introduce some latency or some packet loss, while using an hardware appliance to do the tunneling would give better performance. Okay, so first of all, the service is meant for the switch customers, where we control the whole autonomous system backbone. So security speaking, you always have to think of your attack surface. So it's true that this is a VPN service between switch and the customer, but is not running on the public internet. This is still running in Switzerland within the switch network. So your attack surface would be from another institution in Switzerland. Okay, this already closes a little bit. Then the IPv6 traffic between the two boxes is encrypted, and the management interface is not exposed in a public IP address that is easily accessible from the outside. So I don't know if this answers your question. Basically two things: encryption between the two endpoints, and anyway the traffic is confined inside the switch network, where we have the full control of the infrastructure. Yes, the infrastructure. So if you are in a institution that is connected to the switch network, the traffic to SWITCHengines will not cross the public internet, will only cross links where we fully control the fiber and the routers. So it's not like when you have a VPC to a public cloud provider, like in the US, and then your traffic leaves Switzerland and goes to the US or to Dublin or wherever. This is all inside our network. That's also because that's also why the performance can be interesting. You can do layer 2 because you are not doing VPN very far away. So if there are other questions, I will be happy to pick them up during the lunch break.